The aerospace industry demands high standards of precision, quality, and safety, especially in manufacturing airplane windows. These windows, made from layered material like toughened glass, polycarbonate, and acrylic glass, must withstand extreme pressure and stresses at high altitude. They also include insulation for thermal protection and UV-resistant coating for passenger comfort. Traditional manufacturing methods for these windows are both time-consuming and labor-intensive due to meticulous quality control required at each stage. To keep up with the increasing demand for commercial aircraft, manufacturers must find a way to improve efficiency without compromising safety and reliability. Our group proposes an automated manufacturing plan for airplane windows production designed to optimize speed, minimize error, and enhance product consistency. By integrating CNC machine for precision cutting and robotic arm for automated assembly, the system streamlines production while ensuring strict quality control. The layout incorporates a semi-automated approach, combining full automation for precision tasks like cutting and shaping, with manual oversight for critical stages like final assembly and inspection. This ensures product reliability while leveraging the benefits of automation. Report also assesses the feasibility of this system, considering cost benefits, space utilization, and environmental impact. This proposal aims to meet aerospace industry growing demand for efficient, consistent, and safe manufacturing process.
Hello, so my name is BRADNER ASHLEE with number matrix H3397. So now I will continue on my part, which is manufacturing process and assembling. So there are various manufacturing process for the production of glass mirror. So first is cutting and grinding. Cutting. Large sheet of glass are cut into smaller, which is manageable pieces called blanks. These blanks are roughly the size and shape of the final window. So grinding. The edges of this blank are ground to precise dimension. This step ensures that the glass pieces fit perfectly into the bending molds and later into the craft frame. So for the second process is glass bending. The glass blank are heated in a specialized oven to a temperature where they can become pliable. They are then placed over a mold that shape them into the curved form required for aircraft windows. This process must be carefully controlled to avoid any imperfection or stress point in the glass. So third is optical inspection and polishing. After bending, each glass pile is inspected for optical clarify and any defect. This is very crucial because any imperfection can affect visibility and safety. If any defects are found, the glass is polished to remove them. This step ensures that the windows meet the high optical standards required for aviation. So for the next process is assembly, which is multiple layers of glass and interlayer materials like polyvinyl butyrol or PVB are stacked together. These interlayers help to absorb impact and provide additional strength. The assembly layers are then laminated together under heat and pressure in an autoclave. This process bonds the layers into a single, strong unit. So for the fifth process is machining. The laminated glass is trimmed to the exact size needed for the aircraft. Holes are drilled for mounting hardware and other necessary fittings. This step must be precise to ensure the perfect fit and seal. So this is the last manufacturing process, which is finishing. The window is fitted with various components such as pressure seals, weather seals, and moisture barriers. These components ensure that the window can withstand the harsh conditions at high altitudes. Second is connectors and frame. I also attach these parts help to secure the window in places and integrate it with the aircraft structure. So for the final inspection is conducted, which is to check any defects and to ensure that the window meet all specifications, including size, weight, and optical qualities. Okay, so now I will continue on computer control system, which is first is the computer at the design, also known as AutoCAD, which also give precision and accuracy with detailed 3D models for exact specification, stimulation, and testing. pre-production stimulate to detect issues. Second is computer-aided manufacturing, CAM, which is automated production, which also give planning, convert AutoCAD model into instruction for machine. It also give a better efficiency, which will faster the production cycle with automated setup. Third, computer numerical control or CNC. Precision machining, which also give a high accuracy in cutting and drilling. Flexibility, also give a quick reprogramming for different design. So next is integration and automation. So there are two key points, which is first is integrated manufacturing system. Give seamless workflow for design to produce with minimal errors. Second, real-time monitoring detects and correct deviation instantly. So second is robotic and automation. Automated handling. Robots transport glass blanks and finish windows. Second is consistent quality, high precision in repetitive tasks. So this will give a better efficiency in production while using this automation. So for the third point under computer control system is quality control and data management. So we will have an automated quality inspection because it is non-destructive testing audit using technologies like ultrasonic, laser scanning, and optical inspection to check whether windows for internal defects are clarified without damaging them. So second is data analysis, where we'll be inspecting data to identify recurring issue analysis to prevent minor problems from escalating. The second point is data management and traceability. This comes with two, which is numerical documentation that use precise digital documentation for all stages for production design changes and quality checks, for regulatory compliance and easy defect tracing. Second is process optimization, continuously analysis production data to improve productivity and reduce the cost. So with this, it also comes with a few challenges, which is initial investment. It will give a high upfront cost for this. Like implementing advanced technology requires significant investment in software, hardware, and training, though it will yield long-term efficiency and quality benefits. Second, integration complexity, which is the transaction planning when we use this new production of CCS. Carefully plan integration with existing system to avoid disruption and ensure compatibility between new and old technologies. So future direction of the production. This will mean also the benefits, which it will increase the automation, streamlining process for higher efficiency and productivity. Will also reduce labor input and can reduce human error. Enhance customization. System designed for tailored window features, meeting the growing demand for personalized passenger experience. Third, focus and sustainability. Adopting of eco-friendly materials and green manufacturing process, which also reduce the environmental impact while improving the technology. Okay, so next is human resource. There are five key methods that have been taken, which is to improve the production. So first is skilled workforce, training and development for second. Third is workplace safety. Fourth is process optimization. And fifth is employee engagement. So on the next slide, I will explain it briefly. So for the first point is skilled workforce. There are basically two main steps we can increase our skilled workforce and improve our production life with better engineers and technicians. So for the first step is recruitment strategies, whereby we can linkage with university and partner with them for internship and apprenticeship and tailor curricula for aerospace manufacturing skill. Second is social media and promotional event. Utilize job fairs, aerospace event, and technical workshop to attract talent with experience in aerospace, robotics, and precision engineering. So for the second point is onboarding programs, which is give comprehensive training to new hires with company policy, production process, safety standards, and equipment. Second is mentorship. Assign mentor For new employees, for guidance on technical skills and organization culture, which improve productivity and retention. Okay, so next is training development. So from this, we can give workers continuous learning, such as like workshop and seminars, which offers industrial relevant workshop on new materials like AutoCAD, CAT, CAM tools, lean manufacturing, and quality control. So next point is online courses, enable flexible learning in Six Sigma robotics and CNC training, reimburse employees for complete relevant courses. So next is by giving them certification like professional development that encourage certificate in lean manufacturing and Six Sigma for skill enhancement and operational improvement. The second is in-house training that provides tailored training on specialized aerospace manufacturing skills like handling aerospace glass and operating CNC machine. So workplace safety. So from here, we should maintain our safety at our workplace by following this step. Safety protocols, which is standard operating procedures, SOPs. These ensure are clear, accessible, and updated with regularly trained employees on SOP for machinery and emergency response. We also should provide PPE, supply appropriate personal protective equipment, which is PPE, and conduct regular inspection for safety and functionality. The second is routine check, safety audit. Conduct regular audit to identify hazard and update safety policies as needed. Emergency drill. Regular fire, spill, and first aid drills prepare employees for effective response to emergencies. So for the fourth point is process optimization. So from here, there are two key points like lean manufacturing and Six Sigma. So for lean manufacturing is waste reduction. So we can apply lean manufacturing, which is principle to minimize waste, like excess inventory, production bottlenecks, and optimize resources. The second is continuous improvement, which is foster a culture of improvement where employees participate in optimizing processes. So second is the Six Sigma, which is we reduce defect. Reduction use Six Sigma tools, which is root cause analysis to reduce defects and meet stringent quality standards. So from here, we can apply DAMIC, which is defined as measure, analysis, improve, and control, which is to address inefficiency, systematic, and sustainable. So for the last point for human resource is employee engagement. So from here, we can see that the HR department will get involved directly with the manufacturing department. So here, we can generate new ideas that encourage employee input through suggestion box, workshop, and digital platform for innovative problem solving. Second is decision making. Involve employees in decision relate to their work areas, fostering ownership and commitment. For the second point is acknowledgement, where we give awards and incentive to workers to recognize innovation, performance, and teamwork with awards and bonus to boost their morale. So second is career development, which offer clear advancement path and training opportunities to retain motivated and skilled employees.
Hello everyone, my name is Andros Andrew with matrix number 83224. So now I'll be discussing about the type of machine used in the manufacturing of aircraft window. So for cutting machine, CNC water jet cutters are used and the model will be Aquajet 3020. This CNC water jet cutter utilizes high pressure water to dilapidate thin layers of material away. Oftentimes, the streams of water contain tiny particles of abrasive to aid in the cutting. They offer precision cutting with no heat distortion as compared to if laser cuttings were to be used. Water jet cutters will reduce the risk of thermal distortion and cracking. They are also capable of producing precise cuts with minimal edge chipping. This helps to improve optical clarity of the window panel. Next would be the laminating machine. For autoclaves are conventional laminating machines used for laminating multiple layers of glass or plastics. So the high pressure and high temperature are used to laminate layers of the composite windows and to bond the polycarbonate interlayers. For vacuum bagging system, we utilize vacuum pressure to bond layers of material without the presence of air bubbles, which could cause structural failure of the windows. For drilling and hole punching machine, a CNC drilling machine is used and the model will be Drewry CNC plane drilling machine. Now we know plane windows require points of attachment with the frame of the aircraft. So this CNC will drill a small hole for the structural mounts that are positioned accurately through the user interface of the CNC machine. For coating machines, there are two different types being used, vacuum coating system and a spray coating machine. The vacuum coating system applies thin uniform of coatings to the window to increase the resistance to UV radiation, scratch and impacts. They apply anti-reflective layers, UV filters and anti-fog coatings. For spray coating machine, this machine applies protective coating on the window surface to improve the optical clarity and to increase the durability. Only clear coats are applied in this case. Then we will have the curing and hardening equipment. Heat curing oven is used and the model will be Anda IQ3. This machine is used after the laminating process to help cure and harden the pieces. This machine controls heat to cure the composite materials that are fused together. And for the assembly part, we use heat seal machine and the model will be Brugger Munchen HSGCC. This is used for cockpit windows that need integration of advanced features and heating elements. This machine will infuse the de-icing and heating elements into the window surface. For injection molding machines, this machine is used for the production of window frames and attachment to secure the windows to the aircraft. For the inspection and quality control, however, optical inspection systems are used. This machine is only used after all the manufacturing process is completed, because this machine helps to ensure that the quality of the manufactured aircraft window is controlled. Optical inspection system utilizes cameras and sensors to inspect defects such as scratches and cracks on the window. For packing equipment, we use the heat shrink packing. This integrated system is used to pack the aircraft window for shipment to aircraft assembly points or companies. Now we have the material transportation section. In this section, enhanced safety standards are required for transporting materials for aircraft window because they need careful handling. So logistics of the materials are organized in stages which depends on factors such as material type, location of the processing facility and also the distance from the suppliers. So for raw materials transportation, if we transport glass, the glass panels are shipped in containers with cushioning that are designed to prevent cracks and breakage during the transportation. After shipping, they are brought in flat-bedded trucks that have special coverings. For the polycarbonate and acrylic sheet, large sheets and rolls of polycarbonate and acrylic are also transported by trucks or sea in a climate-controlled environment to prevent them from being exposed to UV rays and extreme heat. As for the sealant and coatings, they are being transported by air freight in bulks or canisters, which depends on the amount required. So for the next section, which is the transportation of the finished product, which is the complete aircraft window. After each window passes the quality control section, they are packed in crates with cushioning wraps to prevent scratches and breakages due to its fragile nature. Transportation of the finished window often depends on the location and urgency of the buyer. We can either transport it by road, rail transport, air transport, or even ocean freight. Handling and loading. Now, because we are handling something that is very fragile, special handling procedures are required during loading and unloading. For forklift and cranes that have padded hooks are used to carry and load the crates into the vehicle to prevent them from being subjected to stress and torsion that might lead to braking. Temperature and humidity control is also implemented, in which the temperature controlled transport are used to prevent the laminated layers from warping, cracking, which will lead to degradation of the structure. Refrigerated contain are suitable. Refrigerated container are suitable to prevent extreme temperatures and humidity. When delivering the products to the aircraft manufacturer, there are a couple of important considerations that must be made when delivering this product to the aircraft assembly plants, which is where it is installed to the aircraft. We must coordinate with the aircraft production schedule. Delivery schedule align with the aircraft's assembly timeline as they are typically installed during final stages. We also conduct inspection during delivery, where final inspections are done upon arrival at the plant to ensure no damage occur during the transit. Storage and identification system. To ensure the quality, traceability, and safety of the manufactured aircraft window, the storage and identification system are designed under great scrutiny. This system helps to manage the inventory but also act as a quality control environment. So there are a few important elements that are considered when making the storage and inventory management system. Firstly, the storage condition. If we consider that the material's sensitivity, especially those windows with UV coatings, anti-fog layers, and other special features, they must be kept away from chemical or other materials that can damage the surface and affect the structure and optical clarity. Stacking and separation. The windows are also stored individually in small batches in crates to avoid contact with one another. The operations are done using soft materials. Now for the inventory management. When handling the equipment, conveyors and automated guided vehicles are used to transport the windows and raw materials from one point to another. As for the rack system and shelving, the finished products are always stored in specially designed racks and shelving units to prevent it from being scratched or broken. The system is wrapped with a cushion to protect the glass and is adjustable so it can also fit larger windows. For the environmental control, facilities will have an environmental control system in which extreme humidity can be controlled as well as temperature variation. The finished products are also kept away from direct sunlight that could affect the performances.
So now we move on to the identification system. There are three parts to this, which is firstly the barcode. Every single window must carry a unique barcode label which identifies itself to help the ease of tracking of the product throughout the manufacturing process and supply. This barcode will include information such as part number, batch number, and production date. For the second one, which is part numbering system, each aircraft window and components will be assigned to a unique part number that corresponds to the design, dimension, and material composition. By doing so, we can ensure that the correct components are used during the aircraft assembly. And lastly is the serial numbering. Serialized numbers. Each aircraft windows will have its own serial number assigned after completing the production. This helps to indicate and identify exactly which windows are assembled to an aircraft for record purposes. For inspection and testing records, there we have two inspection tags and data logging. For the inspection tags, after the windows have passed the quality control checks, they are tagged with inspection certification that indicates the result of visual, pressure, and stress testing. For data logging, the test results of the structure's integrity, load tests, heat resistance, and etc. are stored digitally, which links to the Windows barcode system. In addition to that, the window packaging will also include certification labels from the Federal Aviation Administration to ensure that the product complies with the regulations set by them. Together, this system ensures that every single window is handled properly and are stored with proper tracking while maintaining the highest standard of safety, quality, and regulatory compliance.
This is the proposed plant layout. The design ensures an efficient workflow by integrating automation at key stages of production. Raw material, including acrylic, polycarbonate, and toughened glass, are delivered to the cutting station using automated guided vehicles (AGVs). At this stage, CNC machine perform precise cutting and shaping of the material. After cutting, the material follow separate paths. Acrylic layers are transported via roller conveyor to the UV coating station, where they receive a protective coating for durability and passenger comfort. Polycarbonate and toughened glass bypass the UV coating station and are directly transferred to the finished product section by robotic arm. This efficient system ensures that each material is processed according to its specific requirement, maintaining precision and quality control throughout. The finished products are then prepared for dispatch, while storage area provide space for managing inventory efficiently. In conclusion, our proposed automated manufacturing plant will significantly enhance the efficiency, productivity, and quality of commercial airplane windows production. By automating critical processes like cutting, shaping, polishing, and coating, we ensure consistent quality and minimize errors. At the same time, semi-automation allows for human supervision during essential quality control tasks like inspection and final assembly. This can ensure product reliability. This balanced approach leverages the speed of automation and the expertise of skilled labor. Overall, this plan layout supports long-term sustainability, reduce costs, and enhance competitiveness, positioning the company to meet future market demand effectively.